to Unit 3, which deals with function, as you can see. So we'll start by defining functions first of all. Okay. So when we define functions, we will define them in terms of two non-empty sets. Since we're done with set theory and we're familiar with the ideas of sets, it's safe to assume that everybody right now is familiar with the idea of sets. So we'll define functions in terms of two non-empty sets. Two non-empty sets, A and B. We say that a function maps the set A to the set B with an assignment of exactly one element of B to each element of A. That is, the mapping should be such that each and every element of the set on the left-hand side, each and every element of the set on the left-hand side must be mapped to exactly one element from the right-hand side. Okay? So we are mapping one set to the other, the elements of one set to the elements of another set, for two non-empty sets. And it's mapped such that each and every element of the set on the left-hand side must be mapped to exactly one element on the right-hand side. So the key part here is this, each element of A and exactly one element of B. Why this is a key part, you will see that first thing you'll have to check when you see an expression or something and determine whether this is a function or not. You have to check whether every element of the set from the left-hand side, whether every single one of them are mapped or not. That is the first condition, because each element of A has to be mapped. Each element of A, right? So each element of A has to be mapped. So every element of the set on the left-hand side has to be mapped. So once you see it, you'll have to check whether each and every one of the elements from the left-hand side is mapped or not.
Ma'am,
Yeah.
are these sets domain and range?
Domain and codomain, to be exact. Yeah. But yeah, we'll get to that later. These two sets, yeah, you're correct. That's one is the domain and the other one is the codomain. Yeah. So the domain is the one on the left-hand side. The codomain is the one on the right-hand side. So each of the element from the domain or the set on the left-hand side has to be mapped to exactly one element of the right-hand side. This is the second condition, to exactly one on the right-hand side. This is the second condition. So each of the elements from A that you're mapping, each of them can be mapped to only and only one element from the right-hand side. You cannot have any one element from the set A which is mapped to two elements from set B simultaneously. No, that is not a function. Okay? So each and every element of A has to be mapped and to exactly one element of B. Okay. So the way we represent it is either using FA is equal to B or using a combination of this and that. All right. Here it means that the function maps the set A to the set B, and the expression itself, the function itself, is represented in terms of instances in this format: FA is equal to B, B being the result, B being the result, A being the input. Okay. A will come from set A, and this B will come from set B, obviously. So this input comes from the set on the left-hand side. The result comes from the set on the right-hand side. So we write FA is equal to B, given that for every A which comes from the set A, we have a unique B from set B. All right. So we'll see some examples and hopefully it'll be clearer then. So this is a pictorial representation of a function from A to B. So you see you have the set here, A, B. You'll have the elements of A here, the elements of B here. And each of the elements of A represented by A here, this lowercase a here, is transformed into B. Transformed into B how? By applying the function. You apply the function on this A and then it transforms into B. Okay. So the function transforms A to B or maps the set A to the set B. Okay. Now let's look at an example of a function. This is an example of a function, a valid function, from the set 1, 2, 3 to the set ABC. So you see the set on the left-hand side. The set on the left-hand side has what elements? This elements 1, 2, 3. What is the first condition? The first condition is that each of the elements of the set on the left-hand side has to be mapped. The set on the left-hand side, each of them have to be mapped. You see, each of them are indeed mapped. So that is the first condition fulfilled. Yeah. What is the second condition? Each of them can be mapped to exactly one element from the set on the right hand side. Exactly one. So let's go case by case. So the first element, 1. How many elements is it mapped to? Only 1. Okay, good. Second element, 2. How many elements is it mapped to? Only 1. Third element, which is 3. How many elements is it mapped to? Only 1. So both conditions are satisfied. This is a function from the set 1, 2, 3 to ABC. This is also a function from 0 to 3 to AB, right? You see here, first condition, again, each element from the left-hand side has to be mapped, and they are indeed mapped. And each of them are mapped to exactly one element from the right-hand side. 0 is mapped to exactly one element from the right-hand side. 2 is mapped to exactly 1. 3 is also mapped to exactly 1. Both of these are mapped to the same element. But is that a problem? No, that is not a problem. Both of them are mapped to the same element, but that is not a problem. The two conditions are that each element on the left-hand side have to be mapped and to exactly one element of the right-hand side. So we have to check whether each of these elements, whether they're mapped to exactly one or more than one. If they're mapped to more than one, then that's a problem. However, as you can see, each of them are mapped to only one element. 0 to only 1, 2 to only 1, 3 to only one element, right? This is something that's fine, that's legitimate. Two elements from the left-hand side mapped to the same element on the right-hand side is fine, which is something that you will get as well. So x squared, for example, x squared, if that is your function and your domain or the set on the left-hand side is the set of all integers. So won't you get the same value for the positive and the negative integer? So there you go. That's one example. For example, for -2 and +2, for both of them, you will get the same output. So it's very much possible that multiple elements from the set on the left-hand side are mapped to a single element from the set on the right-hand side. However, the main conditions, the two conditions, whether they're fulfilled or not, based on that, we decide whether this is a function or not. And this indeed is a valid function from the set 0, 2, 3 to the set that contains AB. This is also a valid function. Again, just go by the condition. Are all the elements on the left-hand side mapped? Yes, they're mapped. What is the second condition? Each of these elements can be mapped to exactly one element from the set on the right-hand side. 1 is mapped to exactly one element. 2 is mapped to exactly one element. All right? So this is also a function. This element here, 1 from the right-hand side, this is not mapped. But is that our concern? Is this going to be one of our concerns? Will we be concerned about this?
No.
Why is that? Because we need to check whether each element on the left-hand side is mapped or not. We don't care whether each element from the right-hand side is mapped or not. So in function, basically, every element of the domain has to be mapped, but every element of the codomain not necessarily will be mapped. All right? Every element of the domain has to be mapped and to exactly one element from the codomain. But it is not necessary that every element from the codomain will be mapped. Okay? Now, this is not a function. Why is this not a function? First of all, let's go by the conditions. The first condition is what? That each element on the left-hand side must be mapped. Are they mapped? Each element on the left-hand side? Yes, they are. Each of them are mapped. The next condition, what is that? Each of the elements on the left-hand side has to be mapped to exactly one element from the right-hand side. Has that condition been fulfilled or satisfied?
No, ma'am.
No, it hasn't. Why is that? Why do you say that?
Yes, because A is mapped to two values on the right.
Yeah, A is mapped to two values on the right, which is not allowed. Each of these elements can be mapped to exactly one element from the right. So A here is mapped to more than one element on the right. And this is something that is not allowed. That is why this is not a function. Okay? Okay. This, they're saying, is not a function. Okay? Why is that?
Yes, because B
Because
is
B
not
is
mapped.
not mapped to any elements.
Exactly. And every element on the left-hand side must be mapped. And B is not mapped to any element. So that is why this is not a function. This apparently is also not a function. However, if I look at it, Think about the condition. Every element on the left-hand side, are they mapped? Yes or no?
Yes.
Are they mapped to exactly one element?
Yes.
Yes. Then why is this not a function?
One is not in the domain.
One
I mean,
is
not
not
in the set. Not in the set. Left.
Yeah.
The code.
One is not in the codomain or the set on the right-hand side. Very good. Because this is not a function from AB to 0, from the set that contains AB to 0. So you see, when I asked you the question that whether each of these elements are mapped or not, actually, each of these elements are not mapped. Only B is mapped. A is not mapped. Here, A is mapped to some number 1. Do we know 1? No, we don't know that. We only know the elements that are there in the domain and the codomain. A 1 এর সাথে mapped হলো না 3 এর সাথে mapped হলো, that's not our concern. The function will be valid when each element from the set on the left hand side is mapped to exactly one element from the set on the right hand side. All right? Other than that, we do not recognize any other mapping. So, in fact, A is not mapped at all because A, in order for this to be a function, would have to be mapped to something from the codomain, or that is the set on the right hand side. So here, even though in the first glance it might seem that okay, is mapped, A is actually not mapped at all because by definition of the function, A would have to be mapped to a set to an element from the codomain or the set on the right hand side, which is not the case. Okay, so that's why this is not a function. Any questions so far regarding the definitions of function?
No, miss.
Okay. So some of the terminologies that we'll use, we've already used them, domain and codomain. So we already pretty much know what a domain and codomain is, courtesy of Fahad. So the function f, which maps A to B, which maps the set A to set B, here we say that the set A from which we get our input is the domain. The set B, which the result belongs to, is the codomain. Okay, so the set A is the domain, B is the codomain. Also, the result B is the image of A. Okay, whatever value you have here, for that specific value, the result that you get, that result is the image of that value for this function. And the input is the pre-image of the result. Okay, so here, when we say f A is equal to B, B is the image of A is the pre-image of B. And functions are also termed as mappings and transformations, terms that I've already used. So we know that we can also say that if maps A to B or if transforms A into B, we can say stuff like that. Now, the range and the codomain, they're not the same things. Why is that? Because the range is the set of all the results, okay? All the outputs that you get once you apply the function. The range is the set of all the images, all of the images, all possible images are there in the range. But the codomain and range, they're not the same things. Why is that? Was this a function?
Yes, miss.
And on the right hand side, what do we have? The codomain. Are all elements from the codomain here mapped as a result?
No, miss.
No. 2 here we see is not mapped at all. Okay, that is 2 will probably never be a result in this function, even though it's a part of the codomain. So you see, you can have elements in the codomain which you will never see as results of the function. Okay, you will have elements in the codomain which are never mapped. However, the range contains all the images, that is all the results. Okay, the range, the elements that you will have in the range are all results that you get by applying the function on each element of the domain. Okay, so that is the difference between the codomain and the range.
Miss.
Yeah.
So 2 will not be in the range.
Yeah, 2 is not going to be in the range.
Okay, miss.
2 is a part of the codomain, yes,
But it's
because
not-
it is part of the set on the right hand side, but it's not going to be in the range because for range, in the range we will have only the results that you get after applying the function. That is the images. Okay.
Okay, miss.
All right. So in calculus, what So the use of functions is the functions are so widely used in calculus. Often what you'll see is that a function is defined by formula and that's it. The domain, codomain, none of it is mentioned. None of it is specified. Why is that? Because when it comes to function, we assume that the domain and codomain will be such that it makes sense for the function. Whatever domain makes sense for the function. The largest domain that makes sense for the function and the largest codomain that makes sense for the function. That is, in order for this function to be valid. That is what we assume by default. In most cases, you will see in our course that the domain and the codomain is defined. And based on the definition of the domain and codomain, you'd have to maybe find out what this function would give us as a result, or what would be the range of the function, or something like that. Based on the domain and the codomain, you'd have to do some analysis or apply some logic on the function based on the domain and codomain. You might have something like that. But usually in general, in calculus, for example, the functions aren't defined in terms of domain or codomain. It is assumed that the domain and codomain is the largest set that makes sense for the function, as long as the function is valid. For example, fx is equal to x squared. For this, the domain, you can assume that the domain is going to be the set of all real numbers. Right? The set of all real numbers is going to be the domain. That is, the set of all inputs is going to be the set of all real numbers, because it makes sense that way. However, the same domain will not be assumed for this function. For this function, we will not assume that the domain is the set of all real numbers. We will assume that the domain is the set of all non-negative real numbers, because if you have negative real numbers here, under square root of a negative real number would lead you to an imaginary number, and we don't want that. It doesn't make sense. Okay, so that's why we would, and here we will deal with numbers in the realms of like the set that contains the real numbers. All right, all numbers that are real. So since it's going to make the result imaginary, that's why this function is, for the domain for this function is assumed to be the set of all non-negative real numbers. Okay. Similarly, if you had a function, let's say ix or px or whatever, which is equal to 1 by x, and if the domain and codomain are not specified, then you can assume by default that 0 is not going to be there in the domain. All right? Because 1 by 0 gives you infinite. So we assume something like that. Also, one of the students asked a question in the previous session that here, so we know that square root, if you apply the square root on certain number, what is the result that you get? Square root of 4 is what?
Plus minus
2.
What is the square root of 4 again?
plus minus
Plus minus 2. Okay, so you're saying that in the input you have one pre-image or one value, and it will lead to two different mapping of two different elements from the codomain. That's what you're saying. Here we'll have 4 and here we'll have plus minus 2. That is, 4 from the left hand side will be mapped to 2 and minus 2 at the same time. Is that allowed in functions?
no, miss.
No, it's not. So we assume by default that the codomain is going to be what?
2.
For this function, the codomain is going to be what? The entire function. Is the codomain going to be the set of all real numbers? Can we have the, if we say that the codomain is going to be the set of all real numbers, will this function be valid anymore?
No, miss.
Because we know that we cannot have something like this. We cannot have any element from the left hand side which is mapped to more than one element on the right hand side. If you say that the codomain consists of all real numbers, positive, negative, then you'd have some value from the left hand side which is mapped to two values at the same time from the right hand side. Okay, so in this case, even if the codomain is not mentioned, if it's specified, if it's mentioned, then you have the codomain, and based on the domain and codomain you try to make sense of the function. You'd come to whatever conclusion regarding the function that you need to, if the based on the domain, based on the specification of domain and codomain. If they're not mentioned, if they're not specified, for this function, for example, you'd have to assume that the codomain is going to be the set of all non-negative real numbers or all negative real numbers, all right? All positive or negative real numbers, either one, okay? But not the set of real numbers. Understood?
Yes, miss.
Okay. So basically, the domain and codomain, if it's mentioned, then good. You proceed with that. And if it's not mentioned, then you assume it's going to be whatever that makes sense for the function. Okay, range, we've also already talked about range. Range is the set that contains all the results once you apply the function, all right? That is the set of all images of the elements of A. Each and every element of A, the images that they will have after you apply the function, all those images together, the set of that is the range, okay? So the way we define it is that for all the B, which represent the images, B present in B, that is all, for all the B from the domain, which come from the domain, B is equal to FA. These are the values that we will have in the range. That is the B that you get after you apply the function, okay? The result after you apply the function, those will be there in the range for A being from the domain, okay? Or in other words, you could also say something like this, just FA such that A present in A. That is all the results of this function. Once you apply the function on A, whatever result you get, for each and every element in A, for every element in A, the result that you get after you apply the function, as simple as that. That's how we define the range, okay? Now, let's get into this concept, this new concept maybe for some of you. So bit strings, what are bit strings? Bit strings are strings that consist of bits. Now, what are bits? A bit can be 0 or 1, okay? So bit strings are strings that contain in each position either a 0 or a 1. That is, in each position, you'll have a bit. Okay? So that's your bit string. Now, an empty bit string, what is that? That is a bit string that contains no bits, all right? An empty bit string, not something that will have all zeros. Whether each of the bits in the bit string has a 0 or a 1, whether it's 0 or 1, each of that has significance. 0 has a significance, 1 has a significance. If there are no bits in a string, then that's an empty string, just like any other empty string. Just like any other empty. Jekono string, empty mane ki, there's nothing there. The empty set, what does it mean? There's nothing in that set. So the empty string contains no bits. Okay. Now, if you have 2-bit strings and you say that they're equal, by that you should mean that they have the same bits also in the exact same position. All right. 2-bit strings which are equal to each other have the same bits in the exact same positions. Okay. Very similar to what you had in ordered pair or tuples, right? So 2-bit strings which are equal to each other would have the same bits and in the exact same position. So that should tell you that order is very important in bit string. So remember, we did this in truth tables, membership table. Truth table, you had combinations of true and false and all of that. For each of the variable, they could take either one of 2 values, true or false. For membership table, each of them could take either one of 2 values, 1 or 0. 1 representing the element is present, 0 representing the element is not present. However, both cases, they can take either one of 2 values. Here as well, it's the same thing. Those ideas originate from the idea of a bit string. Each of the bits can take either one of the 2 values. What are those? 0 and 1. Either one of 0 or 1. They can take either one of these 2 values, all right? So if you remember from membership tables and truth tables, for let's say 2 bits, how do we represent it?
0, 1 or 1, 0.
Is that all?
0, 0.
Try to draw the parallel. Try to draw the parallel between this and what you had for 2 variables. If you had 2 variables, how many combinations were there?
4.
8.
4.
Yeah.
If you had 2 variables, you have 8 combinations?
No, ma'am, no, ma'am. 4.
4, yeah. So if you have two variables, you have 4 combinations, all right? So true, 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 false, false, true, false, false, or 0, 0, 0, 1, 1, 0, 1, 1, or 1, 1, 0, 0, whichever way you arrange it. You have 4 possible combinations. Each of those four combinations are bit strings, and each of them are different than each other, all right? Each of those 4 combinations are bit strings. 0, 0, 0, 1, 1, 0, 1, 1. Each of these 4 are bit strings, and each of them are different from each other. None of them are equivalent. 1, 0 and 0, 1. Even though they have the same bits, they're not equivalent to each other. Why is that? Because they don't have the ones and zeros in the same position. 1, 0, 0, 1. Even in truth table and membership table, 1, 0, 0, 1, did they represent the same meaning? 1, 0, 0, 1 এই দুটো combination এর meaning কি same ছিল?
No, miss.
No, it wasn't. So you see, the position of the bits is very important. Okay, so here, for example, 1, 0, 0, 0, 0, 1, all of these are different bit strings. None of them are equivalent to each other, and these are bit strings of length 2. And by length 2, we mean the number of bits that are there in the bit string. Here you have 2 bits in this bit string, 2 bits, 2 bits. So these are all different bit strings of length 2. This is a bit string of length 3. Okay. Any questions regarding bit strings? Okay then.
No, miss.
All right. So let's do an example revolving around bit strings and functions. Okay. Let's say A is a set that contains all bit strings of length 2 or more, and B is a set that contains all bit strings in general. Okay. So bit strings can have the length of 1 as well, right? A bit string of length 1 can either have the value 0 or 1. That's it. 2 possible values. But there is a bit string of length 1. Bit string of length 1 is still a bit string. Okay. So B is a set of all bit strings, and A is a set of all bit strings of length 2 or more. Okay. Now, for the function that is mapped from A to B, as you can see here in this example, the domain and codomain are specified. The function is mapped from A to B. So which one is the domain?
Miss A.
A, which is the set of all bit strings of length 2 or more. And B is the codomain, which is the set of all bit strings. Now, what is the function that we have to apply? The function is that you should be taking the last 2 bits for all the bit strings that's formed in A, all right? That you have in A, For any bit string represented by A, you will take only the last 2 bits, okay? And that will be your result. So what do we have in the domain? The domain is the set of all bit strings of length 2 or more. So whatever the length of the bit string is, whatever the bit string is, what you will do is you'll just go there to the input represented by A here, and from that bit string, you will take the last 2 bits, and that will be your result, okay? So you see, let's say the bit string is 1100. What will be the result?
0, 0.
For the input 1100. Okay. What if the bit string is 00? The input A is 00. What will be the result?
0, 0.
Exactly, 00. So you see, does it matter really what the length is? Because we don't even care. All we'll do is we'll just go there and look at the last 2 bit strings. Okay. Length jai hok na keno, we'll just look at the last 2 bit strings. That is exactly why you have here bit strings of length 2 or more. Because in order to form a bit string, by taking the last 2 bits, at least 2 bit to lagbe. So that's why we have bit strings of length 2 or more. At least 2 jehetu lagbe, ekhane length 2 or more ache in the domain. So it's safe to assume that in the domain, we will always have a bit string which has at least 2 bits in it. At least 2 bit thakle holo. Tahle I'll go there and take the last 2 bits. Now, if you're taking the last 2 bits always for any bit string, what are the possible results that you can get?
0,
Tomar
0.
result thakbe koyta bit. First of all, how many bits will you have in the result?
4.
You'll have 4 bits in the result. But you're taking 2 bits, right? You're taking the last 2 bits.
Yes,
4
miss.
kemne holo? The result I'm just talking about result যে bit string টা থাকবে ওই bit string এ maximum কয়টা bit থাকতে পারে
Two.
আর
Two,
মানে
ma'am.
exactly কয়টা থাকবে 2 result এর যে bit string টা ওটার মধ্যে that one will have exactly 2 bit string because you're taking the last 2 bits. Now if you're taking the last 2 bits you're having only 2 bits there, and for 2 bits how many possible results can you get?
4.
4. Yeah, now it's 4. Yeah, 0 0 0 1 1 0 1 1. These are your possible results for this function. For any given input, the only possible results that you can get is 0 0 or 0 1 or 1 0 or 1 1. Any one of these 4. Nothing outside of this. Okay. So if we talk about the range now, what will be the range of this function? Will it be equivalent to the codomain?
No, miss.
Obviously, it's not going to be equivalent to the codomain because the codomain is a set of all bit strings. But in the result, we will have bit strings of length only 2. So there will be elements from the codomain which are not there in the mapping. Okay. So what will be the range then? What is the range, guys? Range is the...
How do you define this range? Because these are just 4 different combinations.
Yeah, sure. What is range? Range is just the set of the results, the possible results that you can get. Can you get any result other than 0 0 0 1 1 0 1 1?
No, miss.
No.
No. Is it possible to get any one of these results? It's
Yes.
possible to get any one of these results, right? Depending on what you have in A. You can get any one of these 4 results and you will not get anything other than these 4. So your range will be the set that contains these 4 values. That's it. 0 0 0 1 1 0 1 1. That's it. So you see, for any given bit string of any given length, we just directly just look at the last 2 bits. So here the last 2 bits are 1 1. The result is going to be 1 1. So since we're looking at the last 2 bits, we only have 2 bits in the result. So the possible outputs that you can get is 0 0 0 1 1 0 1 1. That is your range because these are the only possible results that you will get. Okay?
Miss, I have a question.
Yeah?
What's this small a? What does it mean? Like a string?
A bit string. Yeah, A represents the input. Any input that comes from the domain.
Okay, miss.
Any element of the domain is represented by A. A could be this number. A could be your 0011. A could be 1001, whatever. A is representing any element that comes from the domain. Yeah?
Okay, miss.
The input and then the corresponding output. Okay? So is this clear to everybody? The range, the domain, the codomain, and what we get here. Any questions regarding this example? Okay.
Mm,
If there are none, then what do you think? What would happen if I changed the domain to be equivalent to the codomain? If I said that the domain is equivalent to codomain, that is the domain is also the set of all bit strings, it wouldn't affect this at all, right? Guys, what do you think?
The range should be different then. The range will be of all possible bit strings.
Why would the range be different? Did the function change? All I'm changing is the domain. I'm saying that the domain, instead of bit strings of length 2 or more, the domain is going to be A. The domain is going to be also the set of all bit strings, just like B. A and B, both of them, the domain and codomain, both of them is going to be the set of all bit strings. Did the function change? The function didn't change. Function to echono same hi ache. Right?
The length could be less than 2.
Very good. Exactly. All right. The length could be less than 2 for what? For the result?
Yes.
For the result. The length could be less than 2. No. That is not correct. That is not correct.
For
So you see, the
A.
function has going to be, the length for A could be less than 2. That is the problem. The
But then
result
the
will
result,
never,
it would also affect the result, right?
yeah, that's where I'm getting to. The result will never have a length less than 2. Why is that? Because the function says so. The function says that the bit string must be formed by taking the last 2 bits of A. So whenever you form a bit string here, you must take the last 2 bits of A. Okay? So the result will always have 2 bits there because the function says so. result কি হবে? Domain আর codomain define করলা। We've already established that মানে result directly সব মানে elements of codomain থেকে আসে না। There are elements in the codomain that are not going to be ever in the result. Why is that? Because the result actually depends on the function. Okay? The result actually depends on the function. So the function says that you have to take the last 2 bits of A. So you'll get 2 bits in the result. But the problem here is that the length of A could be less than 2. The length of A could be less than 2. In those cases where the bit string has a length less than 2, is it going to be possible to take the last 2 bits of A?
No, miss.
No.
No, it won't be possible. So those elements of the domain, will it be possible to map those elements to a result or to an element from the codomain using this function?
No, miss.
No.
No, it won't be. The bit strings which have a length less than 2 will not be possible. It will not be possible to map them at all. So the moment you say that the domain is going to be the same as the codomain, you are making this function invalid. Because remember, every element of the domain has to be mapped. But if you change the domain in that sort of manner, every element of the domain will not be mapped. Because the bit strings which have a length less than 1 cannot be mapped at all. We must take the last 2 bits of A. We cannot do that with the bit strings which have a length less than 2. So in that case, the function is not valid at all, actually. Okay? Makes sense?
Yes, ma'am.
Okay. So we'll stop here so far with the definition of function. From the next session, we'll start with one-to-one functions, onto functions, and all that.